Welcome back, students. So here it is your Arka sir. I have come with another new episode on physics, the current electricity. Already I uploaded one episode on current electricity. Okay. So if you missed that episode, okay, you can subscribe my channel and you can see that episode in my channel. And I will also share the link of the previous episode on current electricity in the description box. Okay. So if you can follow it regularly, so I think all the concept on this chapter will be clear to you. Okay. And if you want to ask me any questions, any notes, any things you require related to this topic, then you can write in the comments, and what type of videos you want to see related to physics. Okay, you can also tell me that in the comment box. I will try to upload that also. Okay. So now, without further delay, okay, I will like to tell you that continue my videos. Okay, don't skip. Otherwise, you will not able to understand properly. Okay, and see up to the end. Okay, so let us start. So in the last episode, I have discussed about the resistance. Okay, and also how we can define resistance from Ohm's law, and what is the actual definition of resistance. Okay, so now the unit of resistance is also I have discussed that it is ohms. Okay, so now factors on which resistance of a material depends. Okay, factors on which resistance of a material depends. So first, suppose this is the conductor or any material, and the length of this material is L, and the cross-sectional area, suppose it is XY. Okay, and the cross-sectional area of the material, cross-sectional area means this one. The material is A. Okay, so suppose what the length of materials is L and cross-sectional area is A. So resistance will be directly proportional to the length of the conductor. Okay, so if the length of the conductor increases, then resistance will also increase. Okay, so I am giving one example. Suppose you have a water pipe. If the water pipe length is small, then what will happen? The water will come very easily from the other end. If what? It is very big, then what will happen? The water have to travel more path and to have to cross more obstacles or friction force with the wall of the pipe. Okay, so that's why what will happen? The water have to do some struggle to come out from the other end. Okay, so just like the current. Okay, if the length of the pipe increases, then what will happen? The length of the conductor increases, then the resistance will also increase. Okay, so it is directly proportional to the length of the conductor. Okay, now when A is constant. Okay, A means cross-sectional area. Now it is inversely proportional to the when L is constant. It is inversely proportional to the cross-sectional area of the conductor. Okay. So if we take any cross-sectional area of the conductor, so it is inversely proportional to that. That means if cross-sectional area increases, then it will offer less resistance, and if the cross-sectional area decreases, then it will offer more resistance. Also the water pipe, I am giving the same example. If I am using very thick, okay, the radius is very big pipe, okay, hollow pipe, then what? More amount of water will come out. If I am using a very thin pipe, the radius is very small, okay, very thin pipe, then what will happen? Less amount of water will come out. Clear? That means very thick pipe, okay, radius is very big, it will offer offer less resistance. Okay, that means what? When the conductor, the thickness increases or cross-sectional area increases, that means what? Huge amount of current or more amount of current can flow through it. and if the cross-sectional area decreases, then less amount of current can flow through it. Why? Because the resistance will increase. Okay, so it is inversely proportional to this. Okay, so now if we take these two equations, R is just what? L by A. Okay, now we want to omit this proportional sign. So what we can write? R is, we have to bring one constant. So we are bringing one constant. This constant is known as, rho. This constant is known as rho. Okay, so it is rho is a constant, and it is known as, and rho is also known as, very important, resistivity. Okay, of the conductor. Okay, so rho is known as what? Resistivity of the conductor. Okay, so that means what? R is equal to rho into L by A. So rho is known as the resistivity of the conductor. Okay, so that means what? You can see that I am explaining. R is directly proportional to the length of the conductor when cross-sectional area is constant. R is inversely proportional to the cross-sectional area of the conductor when length is constant. So if we take these two together, okay, then R is directly proportional to L by A. Okay, now R is equal to what? We are bringing equal sign. We have to bring one constant. So this constant is rho. So rho into L by A, where rho is known as resistivity of the conductor. Now what is the definition of resistivity and what is the unit of resistivity? Okay, so how we can define resistivity of the conductor? Resistivity of a conductor. Okay, so how do we know? Resistance R is equal to rho into L by A. So if we cross multiply, then what will happen? Rho into L is equal to R into A. So rho is equal to R into A by L. Okay, so rho is equal to R into L by, okay, A by L. So A means what? Cross sectional area. A is equal to what? Cross sectional area. L means what? Length of the conductor. Okay, and R means what? Resistance of the conductor. Okay, so that means rho is equal to R into A by L. Now if A is equal to what? 1 unit square. Okay, that means the value of A is 1 centimeter square or 1 meter square, whatever. Okay, 1 unit square. L is equal to what? 1 unit, that means 1 meter or 1 centimeter, and R is equal to also 1 ohms. Okay, that means these three are units. Then okay, we are not taking R. Then suppose A is equal to 1 unit square, A is equal to 1 unit. Then what? Rho is equal to R into 1 by 1. That means rho is equal to R. Okay, so R means what? Resistance of the conductor. Okay, R is equal to resistance of the conductor. Then what we can define? Define means how we can define now the resistivity? Okay, if the cross-sectional area of any conductor is 1 unit square and the length of the conductor is 1 unit, then the resistance of that conductor, is known as resistivity. Okay, so what is the definition? If the resistance of a conductor in which the length of the conductor is 1 unit and its cross-sectional area is also 1 square unit. unit is known as resistivity. Resistivity of that conductor. Okay. So what is the resistivity of the conductor? If the length of the conductor is 1 unit and the cross sectional area is also 1 square unit. Okay. Then if the resistivity of if the length of the conductor is 1 unit and the cross sectional area is also 1 square unit. Okay. In that case, the resistance of the conductor is known as the resistivity of that particular conductor. Okay. So this is what the definition of resistivity. Now, unit of resistivity. What will be the unit of resistivity? What will be the unit of resistivity? See, rho is equal to R into L by A. So what is the unit of R in CGS system? Okay. It is ohm. Unit of cross sectional area centimeter square. Unit of length centimeter. So these will be cancelled. So ohm centimeter. And in SI system it will be ohm meter. Okay. So this is the unit of resistivity. In CGS system it will be ohm centimeter and in SI system it will be ohm meter. Okay. So this is the unit of resistivity. Okay. How we can define the unit or how we can get the unit? Rho is equal to R into A by L. Okay. So R is the resistance, unit of resistance is ohm. Okay. M is cross sectional area centimeter square in case of CGS system and it is the length is centimeter. So it will be what? Only ohm centimeter. Clear? And in case of the SI system, it will be meter square divided by meter. That means only meter will be there. So ohm meter. Okay, very easy. Okay, so this is what? This is known as the resistivity and the unit of resistivity. Okay. So what do we know? Rho is the resistance. Okay. So the reciprocal of rho is equal to conductance. Okay. The reciprocal of rho is known as the conductance. Okay. So the reciprocal of rho is known as what? Conductance. So the unit of rho is what? The reciprocal of resistance. Okay, known as the conductance. Okay. R is equal to what? Resistance. So what is conductance? The reciprocal of the resistance of a particular conductor is known as conductance. Okay. So that means what? If rho increases, then what will happen? The conductance, what will happen? Decreases. Okay. And if rho decreases, then conductance increases. Okay. That means if the resistance increases, okay, R increases, then the conductance to the conductor will increase, and if resistance decrease, then conductor will increase. Okay. Now that means reciprocal. Okay. So unit of resistance is what? Ohm. So unit of conductance is equal to mho. Yes, it is opposite. Okay. It is ohm, mho, mho. Okay. The SI unit of conductance, also another name is there, that is Siemens. The SI unit of conductance is also known as Siemens. Okay. So this is known as the conductance. The reciprocal of the resistance of a conductor, okay, is known as conductance. Okay. Now another term is there, that is conductivity. Conductivity. The reciprocal of the resistivity. The reciprocal of resistivity. Just I discussed what is resistivity. Okay. If the length of the cross sectional area of any conductor is unit 1 unit, okay, square meter, and the resistance, the length is also 1 unit, then the resistance of the conductor is known as the resistivity of that particular conductor. So the reciprocal of that resistivity is known as conductivity. Okay, so it is, okay, the resistivity, okay, so conductivity is equal to what? 1 by resistivity. So unit is what? Mho per centimeter or mho or Siemens per meter. Okay, so this is the unit of conductivity. Okay, so it is what? Mho per centimeter or Siemens per meter. This is the unit of conductivity. So what is conductivity of a conductor? The reciprocal of the resistivity of the conductor is known as the conductivity of that particular conductor. Clear? Okay, so this is what? The conductivity, the reciprocal of the resistivity, and conductor, the reciprocal of the resistance. Okay, so just remember this. Clear? The reciprocal of the resistance is known as conductance, and reciprocal of the resistivity is known as conductivity. Clear? So now, what is equivalent resistance? Suppose in a circuit, in electrical circuit, okay, what is electrical circuit? Where there is the entry and existing path, okay, the current can enter through a path, and after entering to all the devices connected, it can come out from another path. Okay, so this is known as the electrical path. Okay, if both the path is open, that means both the paths are there, that means current can enter and can come out, then that is known as a closed circuit. And if the current can enter but cannot come out, then that is known as open circuit. Okay, so now what is equivalent resistance? Suppose different type of electrical instruments are connected in a particular electrical circuit. Okay, so that means what? Different resistors are there. Okay, different resistors are there. Okay, now how they can connected? They can be connected. Okay, so they can be connected one after another, or any other combinations are there. Okay, so many resistors are there in a particular circuit. So now we want to omit all the resistances. Okay, and from instead of all the resistors, we are giving one single resistance. Okay, so that the flow of current or the potential difference across terminals or the flow of current through each part of the electrical circuit will remain constant. So that single resistance is known as the equivalent resistance of all the resistances which are in the circuit. Okay, so suppose if there are multiple resistor in a electrical circuit, then the single resistance which can replace all other resistances of that circuit without changing to flow of current in each branch of electrical circuit is known as equivalent resistance of all resistances. Okay, so we have understood what is equivalent resistance. Suppose there are multiple resistances are there. Okay, multiple resistances are there in a particular circuit. Okay, So we want to replace all by a single resistance. Okay. So this single resistance we are instead of 3. Okay. We are suppose or any number we are replacing it by R. Okay. So that the flow of current of each branches in the circuit will not change. Okay. So this value of resistance is known as equivalent resistance of all the other resistances of that particular circuit. Okay. So I hope equivalent resistance you understood. Now, what are the combination of resistors? Okay. What are the combination of resistors? There are two combination of resistors. First one is series circuit. When all the resistances are connected one after another. Okay. When all the resistances are connected one after another. Okay. So suppose this one. So suppose this is R1, one resistance. This is R2, another resistance. This is R3, another resistance. Okay. So suppose this is the 2 point, 3 resistors I am taking. Okay. One after another. Okay. It's connected. Suppose it is B, it is C, it is D. So AB is one resistance, BC is another resistance R2. Okay. And CD is another resistance R3. Okay. So these resistance one after another, just like a chain. Okay. It is connected. So this type of combination is known as series combination. Here. So this type of combination is known as series combination. Suppose it is connected now with a battery. So this is positive side, this is negative side. Okay. So suppose the current I is flowing. Okay. The current I is flowing. I is flowing. Current I is flowing. Current I is flowing. Okay. That means what? The same current. Suppose the voltage of the battery is V. Okay. So the voltage at this terminal of the first resistor is VA, and here it is suppose VB, and here it is VC, and here it is VD. Okay. So you can see that the same amount of current is flowing through each resistors. Okay, or each component. Okay, when they are connected in series. But see the voltage difference. Here the voltage difference, the potential difference between these two terminals will be what? VA minus VB. As the current is flowing from A to B, that's why VA will be greater than VB. So the voltage difference will be VA minus VB. Here it will be VB minus VC. Here it will be VC minus VD. So the voltage across each terminal, okay, or each resistance will be different. Okay. So that is the characteristic of series circuit. Okay. So the flow of current of through each component will be same, and the voltage across each resistor or each component will be different when they are connected in series. Okay. Now, how we can find out the equivalent resistance? Okay, equivalent resistance of series circuit. Okay, equivalent resistance of series circuit. Equivalent resistance of series circuit. Okay. Equivalent resistance of series circuit. How we can find out? First, let us consider the three resistors. Okay. So suppose it is R1, just like before. Now you say it is what? It will be R2, and you say what? It will be R3. Okay. Now it is connected with a battery. V, voltage of the battery. Okay. And the current is I. Always give the arrow sign when you are drawing the light diagram or diagram of current electricity, from which to which direction the current is flowing. So here it is A, B. It is second resistor C, and it is third resistor D. So the voltage here is VA, here it is VB, here it is VC, here it is VD. So what do we know from Ohm's law? V is equal to I into R. So from Ohm's law, what you can write? Flow of current Okay, current is I. So for first for R1, what do we know? VA minus VB is equal to what? I into R1. For this one, what? VA minus VB is equal to I into R1. For R2, what you can write? For R2. Okay, so VB minus VC, kindly spell to this direction. So this VB will be greater than VC. So VB minus VC is equal to I into R2. Okay, now for R3. For R3 means what? VC will be greater than VD. So VC minus VD is equal to I into R3. Now if we add, then VB will cancel, VC will be cancelled. Therefore, VA minus VD is equal to I common R1 plus R2 plus R3. Okay. So VA minus VD, that means two terminal which is connected to the battery V. So it will be what? V is equal to I into R1 plus R2 plus R3. It is equation number 1. Now suppose the equivalent resistance, we are now replacing the 3 resistors by 1 resistance only. Okay, so let the equivalent resistance is R. So what will be the equivalent circuit? Equivalent circuit 3. Equivalent circuit. So this all will be replaced by a single resistor. So this is what? This is a single resistor. R1, R2 and R3 are replaced by a single resistor. Okay. Battery will be same. V. Okay. The flow of current will not change. I told that the flow of current should not be changed. So what we can write? V is equal to I into R. From Ohm's law, for this circuit, equivalent circuit, we can write this. Now, what then? By comparing these two, what we can write? It is V is equal to this, it is V equal to this. So what we can write? I into R is equal to I into R1 plus R2 plus R3. So I will be cancelled. So R is equal to R1 plus R2 plus R3. So here I have taken 3 resistors. Okay, resistances. If the number of resistances is n, then what? It will be the equivalent resistance will be the summation of all the resistances which are connected in series. Okay, so if the number of resistance is n, so what will be the equivalent resistance? Okay, R is equal to R1 plus R2 plus R3 plus plus up to Rn. Okay, so that will be the equivalent resistance for n number of resistances which are connected in series. Okay, so this is how we can calculate the equivalent resistance of all the resistances which are connected in series in a circuit. Clear? So I think it is clear to you. Okay, so now the last topic for today video. Okay, the characteristics of series circuit. Okay, the characteristics of series circuit. So let me draw the same diagram for the 3 resistances. It is R1, it is R2, it is R3. 3 resistances I am taking. The battery, this is plus sign, this is minus sign. Okay, B, the current will flow in this direction. Okay, so main current is I. Okay, it is I. Okay, it is A, it will be VA, it is B, it will be VB, it is C, it will be VC, it is D, it will be VD. Okay, now the thing is that, see, flow of current through all the components which are connected or resistances which are connected in series are same. Okay, so flow of current through each resistance which are connected in series is same. Here it is I. So same current is flowing. So potential difference across each resistance connected in series will be different. Okay. So potential difference across each resistance connected in series is different. Okay. Now next, if any component damage or any resistance is damaged, suppose these are the electrical component equipment, any equipment damage, then what will happen? The current can enter up to this but cannot come out. So actually all other instruments which are connected in series will not work. Okay. So suppose in the occasion we use the chain light. Clear? You see in a particular wire, okay, the chain lights are connected. If any light is not working in that particular wire, no light will work. Okay, why? Because it is the property of the series circuit. Okay, that means if any component get damaged, then all the other component will not work. Okay, so this is the property of the series circuit. Okay, so if any electrical component connected in series get damaged, then all the other components which are connected in series with the damaged component will also not work. So suppose if in our domestic purposes, if the fans of our houses or lights are connected in series, then if one fan is not working, then other fan will not work. If one light is not working, so other light will not work. Okay, will not glow. Okay. So these are the drawbacks. This is the drawbacks of the series circuit. Clear? So if any component get damaged, then all the other component will not work. And as the voltage differences, see, VA is greater than VB, VB is greater than VC, VC is greater than VD. That means what? As we move from starting point to end point, then there is a voltage drop. Okay. Or in every point. Okay, so that is what happened actually. So this is the potential difference of this instrument. This is the potential difference. This is the potential difference. So the potential difference across each component will not be same. That means all the component will not work with full efficiency because it is not getting the same potential difference. Okay, so all the electrical components which are connected in series will not work in full efficiency as the voltage drop is there. Okay, so another point, that is the last point. What is that? As there is a voltage drop, as in case of series circuit there is a voltage drop for each component. So all the electrical component will not work with full efficiency. Okay, so this is another drawback of series circuit. Suppose I am using a 50 watt okay, to 20 volt electric bulb, some electric bulb which are connected in series. So first bulb will get 220 volt, second bulb voltage drop will be there, it will be less than 220 volt, third bulb will be lesser than that. Okay, so that means what? The efficiency of bulb, okay, will not be same for all the bulbs. Okay, it will decrease as we move from the first to last. Okay, so that is also a drawback of the series circuit, and even one bulb is not working, then all other bulbs which are connected will not work. Okay, so students, I hope you understand this. Okay, the series circuit, the equivalent resistance of a series circuit. Okay, what are the drawbacks of series circuit and what are the characteristics of series circuit? Okay, many numeric problems are there. Okay, we'll solve that. And in my next episode, I will discuss about the parallel circuit. Okay, and numeric problem we will do. Okay, and then slowly we will move to the Kirchhoff's law and all. Okay, so keep watching my channel. Thank you.